Hey guys, welcome back. In this video, we're going to talk about the GIL in Python, or the Global Interpreter Lock. We're going to talk about why it's useful, why it was created, and how it affects multi-process threading in Python. This is being a great video, so let's jump right into it. Alright guys, so before we talk about the GIL, the Global Interpreter Lock in Python, we have to talk about what a reference count is, alright? Because the global interpreter lock is solving a reference count problem. All right. So let's just create a simple program. All right, and this is just going to run forever. It's a pretty useless program, but it's just going to run forever, just for demonstration purposes. So we're just going to say while var, and then we're just going to say var1 equals var, just like this. So we only have 3 lines of code, and we have 3 different reference counts. We have this one, which is our first, this one, which is our second, this one, which is our third. All right, so let's talk about a little about what a reference count is. All right, so a reference count is essentially just the amount of people that are interested in an object, or in this case, a var. All right, that's variable. So why 3? So this first one, it's obviously it's just this variable, and if the reference count is 0, then the variable is like really not. It just gets deleted. All right, I'll talk about that later. So it starts off with 1, which is just that variable, and then here we have while var, so it's interested in saying while true or while var, so it's interested in this var variable. It's getting that var variable. And then here we have var1 is equal to var. It's also getting this var variable. It's interested in this var variable. So that's how we have 3. Okay, now in C, or Python was coded in C, so in the C code that made Python, we have 3 different functions that manage these reference counts, right? So let's talk about these. All right, so the first one we have is called incref, incref, right? And this is just going to increment the reference count by 1. Okay, so this is just plus 1 into the reference count. All right, then we have our gref, and this, or by the way, this, if you haven't realized already, this is increment for reference count. And dref, or not dref, decref, or decrement ref. This is just going to subtract it by 1. Right, so we're just going to subtract the number by 1. Right, so, and then and actually also here, what's happening is if the reference count is 0, then it's going to call another function called delref. All right, and this is just going to delete the variable. Really, it's going to take away that data. So when the program stops, then when you close your program, then that's going to be obviously from the RAM. So because if it's not, then it'll stay permanently. So you don't want it to hog up all the memory. So this is just going to delete it. All right. So this is saying, this is not only subtracting, it's saying if we subtract, and then after we subtract, if the reference count is 0, then we call this right here. All right. So these 3 functions are how we manage our reference counts. Now, I'm just going to erase this for a second. In the 1990s, the early 1990s, an idea called threading came to be. So threading just allows us to run multiple processes at once. All right. So, for example, let's say that we have a program that is that is going to has to wait some time. All right, and it waits some time to do something. All right, for example, maybe it takes some time to retrieve some data from a really long database. All right, or let's just say it takes some time to do that. That's a bad example. So let's say that here, let's think of an example, something that would take a lot of time. Maybe we are running through a lot of different, like data, for example, in a neural network. All right, so it's going through all its data. It's the training phases could take like minutes, right? So this, let's say someone has to go on and it's performing a neural network. Now, this may take some time. And because this is taking time, it doesn't want to slow down something else that is essential to the program, right? So just because someone is, like on Google Docs, right? This doesn't happen, but let's say that they had some neural network that is trying to take everything that you've typed and is trying to trying to give you suggestions. And obviously in Google Docs, this happens in, like milliseconds, right? It shows up immediately. But let's say it took a lot of time. Now, because this takes a lot of time, it doesn't want to slow the whole document down, right? It doesn't want to slow the whole document down. Or a better example is magnitude of text, right? It doesn't want to slow the whole document down. It doesn't want you to stop typing because it has to compute some the neural networks on it, right? And I have a video on demo of magnitude of text if you'd like to check that out. I'll put it in the description. So threading just allows us to run multiple processes at once. So, for example, if we're doing this process, it's taking some time. It just switches over to this one, and it can do something else on this process. So it doesn't stop the whole program because something is taking lots of time. All right, so that's threading. And let's see how that has anything to do with our reference counts. Okay. So let's say that we have two threads. Okay. So we have a thread 1. All right, and then we have a thread 2. All right, and we have our var variable right here, and we'll say our reference count is up here. So right now, because both of these threads are interested in our var variable, we have a reference count of 3. Okay, so basically, in layman terms, what these threads are going to do is, let's say that they want to get this variable. They're interested in this variable in some way. So this first thread, this is thread, yeah, it's a T, not an I. So this first thread is going to do three simple tasks, three things to get this variable. All right, in layman terms. So first, it's going to load the reference count. So it's going to load var x, and it's going to load the variable. So we'll say var. All right. Right, that'd be better. So it's going to load var x, which is the reference count, and then var. All right. And also this other one, let's say it's the same exact thing, or yeah, it needs to get this variable too. This is just going to load var x and var. All right. The second thing it's going to do, so loading now, it's already captured the variable. Okay. And so now it doesn't need this. It's not interested in the variable anymore because it already has it. It already has that variable stored. So now it wants to decrement the reference count because it's not interested in anymore. So it needs to the reference count it's not interested. So the reference count has to go down, right? So we're going to call this decrement. All right. and decrement AX, right? Because that's the variable. And this is just going to take this reference count off. So now this is going to change to 2. Okay. And yeah, so this is good. All right, and that's just gonna store X. So store AX. So it's just gonna put it back. Right. So it's going to put it back as 2. Okay. And now this T2 is just doing the exact same thing. All right. So now the reference count is 1, and that's perfect. And just as this thing, it stores X, stores AX, and the reference count is 1, and that's correct. That's perfect. But what happens is these 2 threads are going to be running at practically the same exact time. So it's not going to happen where thread 1 is going first and thread 2 is going next, at least in regular threads like this, multiprocess threads. So it's not actually going to work like this. How it's going to work is at almost the same exact time, these 2 are going to run. Okay, so it's going to load var. All right, so these both run. This works. And then it decrements. All right, it decrements it. So now this is 2, but since this is running at practically the same time, it also decrements it. So this is also 2. And now this decrement stage is done. So when we store the variable, it's 2. And that's not correct. It should be 1, right? So that's what's really happening here. There's this problem. It's 1 too high, and this is permanently stored. So now we'll always be 1 too high from our 1. So that's a problem. So what happens is now when we close our program, we'll still have 1, so the data won't be deleted. But an even worse problem is if this the reference count goes to 0. So if we do the opposite, and instead of going higher, it goes it goes lower, right? Which could also happen in a different case. Now what happens is the reference count is 0, which would delete the data, right, of the variable. And now when it's deleted, if someone else wants to get the variable, well, there's no reference count. The data is deleted. So the program at best would crash. And yeah, so the program would crash. So that's why we have this huge problem here. So what Python did was they created something called a lock. So we're not yet at our global interpreter lock. We just have a lock. And this says that lock just says that when someone is in charge of or is interested in a variable, a thread is interested in a variable or an object, then they have this lock. And when someone's interested in it, no other thread can access it. So what happens is we have this var variable, and this thread 1 first gets access of it. That it works perfectly. They use it. Now, if thread 2 does that at the same time, it doesn't work. It doesn't work because we have our lock, right? So it's locked. So this doesn't work. And now after this is done, then this works. So really what this lock says is that we can't have these 2 do this at once. So we can't have these 2 threads use the variable at once, and that slows this thread down. But we have to do that because we can't have the data getting deleted, right? So that happens, and then once this guy is done with it, then the lock comes off, and then this guy gets it. So this guy can't access it. So just like that. And that works fine. But now we have another problem here when we try to get the variables like alternately. Let me show you what I mean by that. So let's say thread 1 is trying to let's say we have 2 variables. We have var and then we have var1. All right. So the thread 1 is trying to get, so it says load var, and then it wants to load var1, and this loads var1 and loads var, like this. Okay, so and actually in the last step it just can't reach the variable. So it's really this thread is running, and then after this thread is done, then this thread runs. Okay, so yeah, so now first we have this variable, so this gets it, and this gets its variable. Okay, it's running, and then this gets this tries to get this variable and it doesn't work, and then this tries to get this variable and this doesn't work. So now both programs both threads are stopped. Okay, and we fix this problem with Python fixes problem with the global interpreter lock. So essentially what the global interpreter lock is it says that because I have this lock, I am the only thread that can be interested in any variables or any objects as long as I have this lock. And once I'm done getting everything I need, then I lose it, and then someone else can have it. All right. So now what happens is we have the same case, right? And we have var and var1. So now let's say that T1 gets the global interpreter lock. So when it gets this lock, all right, now it can do its things. Okay, so it loads this, and then it loads this too. It gets these things, then it goes away, and then this guy gets the lock, and then he does his things. So now we have our sorry guys, it's really messy here. And then we have our case again, where this guy loads var, loads var1, and it runs without a problem. Now, what is the problem here? Like, what is happening to this multiprocess threading? Now, this solves the problem that we had earlier with the global interpreter lock, but now what's happening is, or that also was happening with the lock, is that we can only have one thread running at once. So really, it's not it's not like the threads aren't running at the same time. One's running, and then once this stops, the other one runs. So we'll say this is T1, this is T2, and then it stops, and then another one can run. So it's there we have this problem with the global interpreter. All right, guys. So I have a program, just a simple program that I wrote in Python to show you an example of the global interpreter lock. All right. So for those of you guys who do not understand this code, I'll just explain it briefly right now. So basically, firstly, I'm importing time in thread. All right. So time is the built-in time module in Python. This just allows us to wait for like some seconds in this program to make the program sleep for some seconds. Why? Because we want to show this threading. Kind of the one of the main reasons why threading was created was it allows us to not stop the whole program because one one function is taking a long time. So that's why I want to demonstrate this time with this time module. And then I have our threading module, and this just allows us to run threads. So here I have a function called thread, and this just takes two parameters, name and wait. All right, name is just to print out, like what thread is running, which you'll see. And then wait is the time that each thread is taking that we pass. Okay, and we pass it right here. So inside here we set I equal to 0, and we're just running this while loop, and this while loop is while loop is going to run 4 times, and essentially all it's doing is just sleeping for the time that the thread is, how long it's set to, and then just printing, running, and then the thread. Okay, so it's showing us that this first iteration is finished, and then just adding 1. So that's why this loop runs 4 times. And then finally, when it is done with its 4 iterations, it says that the thread has finished its execution. All right, so this will show us the global interpreter lock, because with threads, what's happening is all 3 of these should be running despite the time it is, right? One thread is running and the other one is 2, right? So we can see that it's not going to, it's going to go how we planned, because we already know about the global interpreter lock, but it's not going to run like at the same time. So you can see that we ran thread 1 first, because in our code we did that, and then we run thread 2, but then we run thread 1 before thread 3, because you see how the time for thread 1 is 1 second and 3 is 3 seconds. So thread 1 can run before thread 3, and then thread 3 runs, and then we have the same pattern again, and then after 4 iterations, 1, 2, 3, 4, we have finished thread 1, and then thread 3 runs, and then we finish thread 2 because it's 2 seconds, and then finally do 3. So that's how this works, and finally, with our last iteration of 3, we finished the third execution. So you can kind of see how these threads kind of showed us the global interpreter lock in this program. So for this final part, I'm going to show you guys a real typed world example for our GIL. So essentially, I wrote this program, and this is some Python code with some Flask code, and I'm doing this because I just released a Flask full tutorial 2 days ago. So yeah. So I'll put the link in the description if you'd like to see that. But basically, what this code is doing is it's importing thread, and it's just saying that we're just going to add a user, and then we're just going to delete a user. So just really simple code. And then we're supposed to do this at the same time, because we have 2 threads, which we know is not going to happen because of the GIL. So if it does happen at the same time, what's going to happen is we're going to get an error, and the error is going to be like, sorry, we can't get this, or sorry, empty list, something like that, because we haven't fully added the user before we're trying to delete it. All right, so let's run this and see if we don't get this error, then we're good. So let's run this again. All right, so now let's go to our page. And here what we can do is we can change this URL endpoint up a bit. So basically this endpoint is /add user / and then an ID that I would like to give it. So 345 we'll say, and then test5 we'll say, and then test5, just like this. So when we enter, we can see that we have this all done. So if it wasn't, then it throws us an error here. But yeah, so that's it for this video, guys. I hope you guys enjoyed. If you guys did, please hit that the like button down below. If you have any questions or comments, you can put them down in the chat below, and I'll try to respond to them. And if you have any requests for other videos, you can also put them down in the comments down below. But anyways, once again, that's it for this video. Thank you guys for watching. Peace.